Hello students, so here we go. We are still doing exercise 1C. There's a 10th video I'm sending you today. So in this video, we're going to do question number 2. So from this exercise 1C, the question number 2 reads, express 16,380 as prime factors. So if you have seen the other videos and if you've seen how I've solved question number 1, then question number 2 will not be much difficult. Only thing is that here the number is bigger than those in question number 1. Okay, so I'm going to show you number 2. Let us see how to find prime factors of this number. Okay, so the number here is 16,380 and we have to find the prime factors of this given number. So we do the same way. First of all, remember students that you have to by heart the prime numbers. So these are all prime numbers from 1 to 100. Okay, it doesn't mean that only up to here. Prime numbers are endless. Okay, since the natural numbers are endless, there's no end to natural number. The prime numbers also have no end, but these are some important prime numbers that you should try to by heart, which are up to 100. Okay, so as I told you in the previous video, in this previous sum, that whenever you do prime factorization of any number, big or small, first you should always start with 2. So because 2 being the first prime number, we should try to divide by 2, and you know that any given number can be divided by 2 or can be factorized by 2, the prime number 2, if that number happens to be an even number. And yes, 16,080 is an even number. Remember students, how to find even number? To check even number, this unit is it, this unit is it, this unit is it, should be either 0 or 2 or 4 or 6 or 8. Since it's 0, obviously it's an even number. So let us divide by 2 for prime factorization. Okay, so I cannot take 1 because 1 is smaller than 2, so we'll take 2 digits. We take 1, 6, 16. So now recall table of 2. 2 8s are 16. 16 minus 16, 0. Imagine that there's small 16 here. 2 is a 16. So 16, 0. Now who's the 3? Only 3. So let's do 2 1s are 2 small. 2 2s are 4. 4 is going to be bigger than 3. So we'll not take back. So we'll not take 2 times because it will give us 4, which is bigger. So we'll take 1 time. 2 1s are 2. Imagine the small 2. 2 1s are 2. 3 minus 2 1, and that one goes and joins 8 from the left, so means 1 and 8, carry 1 and 8 becomes 18. And you know table of 2, 2 9s are 18. So this was 18 and now we have 18. 2 9s are 18 equal, so 8 minus 18 is 0, nothing to carry. Then finally 0 is left and then 2 zeros are 0. So here we have seen that we have been able to divide the given number by 2, but the corresponding number that has come also has again unit digit 0. Since it's 0, that means it is also an even number, and this even number, we should carry on with again the prime number 2, the prime number 2. Okay, so let's divide then. Since 8 bigger than 2, so 2 4s are 8. 8 minus 8, 0. Please say carry 0. That means now whose turn to be done divide? 1. Here is the main part where students do mistake. They do what, 2 9s are 18 directly. It's a turn to take only one digit one time, because whenever you divide in this way, find the prime factorization, you should take one number one time, okay, at a time. So 2 4s are 8, 8 and 0 means it's only single one, so that's why we'll not do. And see, look, 2 1 times 2 big, so we'll not do 1 times, we'll do 2 zeros are 0. Okay, 2 zeros are 0. See how? Let me tell you. No, let me show you divide also. 8190. Because I'm dividing by 2. 2 4s are 8. So it's only one term, not 19. Only one. Then 2 zeros are 0. 1 and 0, 1. And now it's 9's turn to come here. Now it become 19. So here also 2 4s are 8. 2 0 0. 1 minus 0 1, and that one goes and join with 9, become 19, like this here, 19. So it's 19. So now table of 2, 2 9s are 18, because 2 times are 20 big, so 2 9s are 18, like this. So 2 9s are 18. Remember, it was 19 first before, because of that carry. So 2 9s are 18. And 19 minus 18, 1. That one goes and join because the carry 1 is there. So that one goes and join with 0 here from the left. So 1 and 0, 10. 2 5s are 10. See here also. 9 minus 8, 1. And now it's 0's turn, the last 0's turn. And 2 5s are 10. Okay. So divide complete. 4 0 9 5 here also. 2 4s are 8, 2 is 0, 1 is 0 1, 1 is 19, 2 9s are 18, 9 is 1, 1 is 10, 2 5s are 10. Okay, so in this way we have divided by 2. But now the question comes, can we again continue to divide by 2? Then to be able to divide by prime number 2, it should be even number. But as you know that if the unit digit happens to be 1 3 5 7 9, I repeat 1 3 5 7 9, then that number is an odd number. 1 3 5 7 9 is an odd number. That means 4095 is an odd number because of this 3 unit digit 5. And you know that odd numbers we cannot divide by 2. So that means now you can no longer divide this given number or this corresponding number coming from here, cannot divide anymore by 2. So since you cannot divide by prime number 2, now you try by 3. And if you have seen the last video properly, nicely, then you know that I have told you how to test whether a given number you can divide by 3 or not if the number happens to be big. Remember, what is the test for divisibility of 3? To find whether a number is divisible by 3 or not, the trick is very simple. The test is very simple. The test says that you add all the digits of this number. If the sum, the total, is a multiple of 3, or the total which you get is present in the table of 3, then this number is also divisible by 3. You can try to divide by 3. Okay, you can divide by 3. Okay, so let's find the sum. 4 plus 0. So let's find the sum. 4 plus 0 plus 9 plus 5. 4 plus 0 4. 4 plus 9 13. 13 plus 5 18. And 18 is a multiple of 3. 3 6 18. So yes, 18 comes in the table of 3. See, this, see, 4 plus 5 9, 9 plus 9 18 means 18. Total is 18 and 3 is 18. Yes, we can divide by 3. So let's divide by 3. The first will do 4. Find 4 is bigger than 3. So yes, 3 ones are 3 because 3 2 is 6 big. So 3 ones are 3. 4 minus 3 1. 1 goes and join with 0, that become 10. And table of 3 is 3 3s are 9 because it's 10 here, that we should take less than 10. The 3 3s are 9 because 3 4s are 12 big, so 3 are 9. So 10 minus that small 9 which is there, 3 3s are 9. 10 minus 9 1. Now that one goes and join with 9 to become 19. Again table of 3 3 6 are 18 because it should be less than 19 or equal to 19. So 3 6 are 18. 18 is less than 19. So 3 6 are 18. So 19 minus 18. 19 minus 18 1. That one goes and join with 5. The 1 and 5 15. And 3 5s are 15. So in this way we have divided by 3. Now let us again see whether we can divide by 3 again or not, because as you know, by 2 we cannot divide because still it's odd number. Once gone means will not come again. Okay, the odd number can divide 2. Now since we have done by 3, so let's try again whether we can divide by 3 or not. So for 3, remember, you have to add again all and see the total. 1 plus 3 4, 1 plus 3 4, 4 plus 6 10, 10 plus 5 15, and 3 5s are 15. Total is 15 and 15 is a multiple of 3. So yes, we can divide by 3 because total is 15 and 15 comes in the table of 3. So let's divide by 3 again. If I take only 1, the 1 is smaller than 3, that's why I should take 2 digits. Now it's 13. 3 1 is 3, 3 2 is 6, 3 4 is 9, and 3 4 are 12. 3 5 and big, so 3 4s are 12. 13 minus 12, 13 minus 12, 1. That 1 goes and join with 6 to become 16. So 16, so you know the 3 was 3 table, 3 5 are 15 because it should be less than 16, 3 5 15. The 16 minus 15, 1. Again that 1 goes and join with 5 from the left to become again 15. 3 5s are 15. Okay, so you have seen that we have completely divided this number by 3. It comes 455. Now again same thing, we should try again by 3 because last prime factor was 3. So again we should try by 3. Let's see whether we can divide by 3 or not. Let's add again. 4 plus 5 9, 9 plus 5 13. This time the sum is coming 13. Now tell me, does 13 come in the table of 3? 3 1 is 3, 3 2 is 6, 3 3 is 9, 3 4 is 12, 3 5 is 15. See, 13 does not come in the table of 3. 13 doesn't come in the table of 3. Okay, so that's why this 455 we cannot divide by the prime number 3. We cannot divide by the prime number 3 because the sum is coming 14, and 14 is not a multiple of 3, so it means we cannot divide by 3. If we cannot divide by 3, then we should try now by 5. And yesterday and in the last video I've showed you that how to test a number whether we can divide by 5 or not. For a given number to be able to divide by 5, divisible by 5, the unit is at unit, tens, hundred, thousand. The unit digit should be either 0 or 5. 0 or 5. Since there's 5, that means now we can divide by the third prime number 5. Okay, so let's divide by 5 because it's confirmed that we can divide by 5 because the unit digit is 5. So let's do that. If I take only 4, the 4 is smaller than 5, so we should take 2 digits. Now it's 45. So I hope you remember table of 5. 45. So 5 nines are 45. 45 minus 45, 0, no carry, so it's only 5 turn, and 5 ones are 5. Okay, so see, we have been able to divide by 5. Now we'll continue further. Now can we divide this 91 by 5 again? Because by 2 we cannot divide, is odd. By 3 cannot divide because already once you cannot divide by 3 means later on also you cannot divide by 3. So 9 plus 1, 10, moreover 10 doesn't come table 3. Now should we continue by 5 again? Again same thing. For a number to be able to divide by 5, the unit digit should be either 0 or 5. But see, it's 1. It's not 0. It's neither 0 nor 5. So it means we cannot divide by 5. Now since 5 also is not able to divide this 91, see, 5 is not able to divide this number. 5 is not able to divide this number 91. So it means now we should try by 7. And for 7, as I told you, there is no test. So for that you have to divide in the half. So let us divide this 91 by 7. Next prime number 7. By 2 we can divide, by 3 we can divide, by 5 we can divide. So now our next prime number is 7. So let's try the 7. 7 ones are 7 because 7 to 14 big. So 9 1 7 2, and 2 and 1 21, and 7 3s are 21. So yes, students, 91 we can divide by 7. See, the remainder is coming 0. Okay, the remainder is coming 0. By 7 when you divide 91 in the half, you'll get remainder 0. Yes, by 7 we can divide. So let's divide by 7. 7 ones are 7. 9 1 7 2. The 2 goes in join with 1, 21. 7 3s are 21. Okay, so we got here 13. Now I've already told you so many times that please by heart all these prime numbers. If the prime numbers are memorized properly, nicely, then you know that the moment you see here 13, then you'll remember that 13 is a prime number. And I've told you in the last video also, I've told you so many times that whenever you see any prime number while doing prime factorization, then those prime number should be divided by the number itself. No need to waste time. Okay, because prime numbers are those numbers which have only two factors, 1 and itself. Means this 13 I can divide either by 1 or by itself, but we never divide by 1 because 1 is not a prime number. We are finding prime factor. So option left is what? Only 13. We divide by 13. So let's divide by 13 because it's a prime number. 13 ones are 13. Okay, and see, we have got 1 here, and once you get 1, then we should stop. Yes or no? So that means now we can write the prime factorization. So therefore prime factors of 16,380 is equal to what? So see, we'll write this as product form: 2 into 2 into 3 into 3 into 5 into 7 into 13. So this is a prime factor. So if you look only what are the prime numbers here, you'll find the 2, 3, 5, 7, 13 prime numbers. That's why 2 will not repeat 2 times. We'll just write 2 one time, and how many times 2 coming? 2 times, so we'll make power 2 square. 3 into 3, that means we'll write only prime number 3, and then how many times it's coming? 2 times, write power. 5 is a prime factor, but it's coming only 1 time, write power 1. 7 is a prime factor, it's coming 1 time, write 1. And 13 is also a prime factor of this number, and it's coming 1 time. So means we have done the prime factors of 16,380. This is the answer. Okay, thank you, students.